Hello everyone. Today I'm going to talk about overfitting, which is one of the most fundamental problems in machine learning as a whole, not only in deep learning. So this overfitting involves understanding the complexity of the model. In other words, usually we want to develop a machine learning model that performs well not only for our training data but also for our testing data as well. So let's say that you need to describe this data and you have fitted a model like in this left hand side plot, which is a straight line. But you can see that this straight line is underfitting the data. That means the model complexity of this straight line is not large enough to capture the entire model characteristics. So let's say that you need to describe the data points which is in this scatter plot. And if you go with the model in the left hand side, it is basically underfitting. That means the model complexity is not large enough to capture the all dynamics in the data. Or else what you can do is you can go with the model in the right hand side. That is overfitting. That means the model complexity is very large. Because of that, it's kind of memorizing all the data points. So actually this overfitting is also not good because when we give new test data for this model, it will fail to generalize this model to predict the patterns of this test data. So what we can do is without fitting much complex model like this, we will fit the like a model which is in this middle, where it will the model complexity is not very complex compared to this right hand side model, but it will do a very job in terms of generalizing this model that we observed based on the training data when we have new testing data as well. So now someone might have a question about how to get rid of this overfitting. The most general answer for that is regularization. So what is this regularization means? Regularization means we are going to constrain our optimization problem to avoid very complex models. So if you do something like a linear regression model or a logistic regression model, what we are going to do is we are going to add this L2 norm or L2 penalty or L1 penalty for our regression coefficients. That's what we call the penalized regression. But in deep learning, in order to do this regularization, what we are going to do is we are going to use a technique called dropout. So let's understand this technique dropout using a simple neural network. So let's say our neural network is like this, where we have this input layer and we have this output layer, and also we have these hidden layers. So in dropout, what we are going to do is we are going to randomly select some of these nodes in our hidden layer and make it to 0 with some probability in each of the iterations. So in each iteration, it is going to drop new set of nodes in the hidden layer. For an example, in the next iteration, it is going to drop complete set of new nodes in the hidden layer. Because of that, what will happen is it will create different pathways through this network. And as a result of that, what will happen is this network will not rely on a particular path, and ultimately it will create a sample of new models which will be helpful to generalize when you have unseen data. So another simple technique that we can do in order to get rid of this overfitting is called as early stopping. So in this early stopping, what you are going to do is we are going to stop the training of the model when it is going to overfit the data. That means we are going to stop training the model when the testing error is getting worse. So that means when we plot our training error and testing error together, we will always see this kind of a plot. That means our training error will always decrease in like this. But our testing error, first it will decrease, but at a certain point it is going to increase again. So what we are going to do is we are going to stop at this point where it is going to increase again. So that is what we call early stopping. So in this early stopping, you don't want to stop very early. In that case, it will underfit the data. But at the same time, you don't want to keep training until you overfit the data.